I'm diving into a wave, I hit my head, everything went numb. Everything became extremely serious when I first met with the doctors that said, you broke your spinal cord, you're never gonna be able to walk again, and this is how it's gonna be for the rest of your life.
Spinal cord injuries are pretty much permanent.
But why accept these limits? Maybe we can come up with an artificial interface.
So we looked at this as an important problem to reanimate the limb of a quadriplegic.
100 years ago, the thought of someone leaving the planet and going to space was crazy. When I broke my neck, the thought of me using a computer to regain use of my body was crazy. But now that's exactly what I'm doing. With my level of spinal cord, I can move my arms around pretty well, but I can't move any of my actual individual joints or fingers on my hand. About 2 years after I had my injury, I kept asking my doctors, what can I look forward to? What's the future gonna be like? I was fortunate enough to be in the right place at the right time when they were looking for patients for this study.
In a spinal cord injury, the communication between the brain and the body has been damaged. So our idea was to create a bridge around that damaged spinal cord so that we could regain control in a limb that was paralyzed. You've got sort of a similar pinch for another grip is going to show a similar pattern.
Exactly.
The system works by allowing the stimulation sleeve to electrically shock your muscles to make them contract and move.
We put the electrodes on and we use pre-programmed stimulation to evoke motions in the hand, wrist, and fingers that we would plan to use with the full system. If we're successful, then we enroll them into the full study.
And then came that million-dollar question.
Would you like to be able to control this stimulation device with your thoughts?
The basic three components of the NeuroLife system is the chip in the brain and the ability to collect that data, the computer that takes those signals and decodes the intent and then re-encodes those to deliver those to the third part of the system, which is the stimulation system that actually evoke the muscle motions.
Sort of the range of bad things that could happen are having a stroke, getting pneumonia, not being able to see or hear. There's always the risk of death with a surgery.
We all make it down except for I.
We are ready. Rubber shot.
The first day where we were able to take all the parts of the system and connect them together to see if this would work was something extremely exciting, but also nerve-wracking at the same time because no one knew for sure until we were able to connect everything together and for me to actually think about opening and closing my hand.
Good. Good thing.
That first movement was amazing. It's almost something that there are no words for, because naturally speaking, this is not something that Ian should be able to do. This should be something biologically that is impossible.
This is the first time that the limb of a quadriplegic has been reanimated using a brain-computer interface to regain fine motor control.
After we were able to get that initial movement of my hand, we really went to the drawing board and said, okay, well, now what all can we do with it?
But the problem? This tech is typically limited to small-scale trials, and patients like Ian could only utilize it in the lab, not at home, where it was needed most.
We've come a long way, but up until today, you could only get access as part of a multi-million-dollar clinical research study. That is changing.
And before that happens, BlackRock is turning to patients like Ian to truly understand how this tech could be life-changing for people with disabilities outside the lab.
We're already today talking about a patient population of 600 million patients that suffer from neurological disorders. I think this kind of technology, a neural interface with various different applications, can and will provide a life-changing impact to millions of patients.
The disabled community is the launching point, but next-generation applications could expand to blindness, depression, and beyond.
Really what we're trying to do is open it up to others to build additional tools, interfaces to enable people to do their jobs, novel classes of computer games and entertainment. Eventually, this may be something for first responders, military or others that may be able-bodied but need faster reflexes or support to be safer in certain environments. It's endless, the possibilities.